Hello, am I audible and is my screen visible? Yeah, all right. So, hi everyone, my name is Anton, and today we'll be going through a pretty common type of algorithm that you will be encountering throughout your journey, and those are called greedy algorithms. So, yeah, let's get started. So today's topics are we'll discuss what is the greedy approach, and we look at some examples. There's not a lot of theory there, so we'll be going through more examples rather. And finally, we'll go through the limitations of the greedy approach. So, yeah, let's start. So, what is the greedy approach? So, throughout your journey, you'll come across certain problems that require you to maximize or minimize a given metric, so or a score. In such cases, your program or your algorithm needs to make some choices. So now, greedy algorithm comes in such kind of problems, and it works upon the idea that making the best choice available at each stage will hopefully lead us to the globally optimal solution. So the globally optimal solution is what we want, and the greedy algorithm we hope that it lead us to the solution. And I'm mentioning hopefully because again I'll come back to it during the limitation section. But for now, let's see how a general greedy approach will look like. So you start with the initial state, and from there you look at all the available choices. Right. So at each point, you would have to pick the choice that seems best at that particular moment. So the greedy approach doesn't care about what comes later or what has come before. You choose the best option at that moment. And you go to this new state and you repeat the process until you have reached the end of your states. So we look at an example of how you would this works. So let's look at this. There are n students numbered from 1 to n, and each student has a level associated with him or her, and that is denoted by in the array ai. So there are n numbers, and each number is the level of the student. So now your task is to split the students into stable groups. And what are stable groups? A group of students is called stable if in the sorted array of their levels, no two neighboring elements differ by more than a given value x. So, for example, say that x equals 4, and you're given this array 1, 2, 5, 7, and 8. So you can see that this is a stable group because the difference between 1 and 2 is 1, 2 and 5 is 3, 5 and 7 is 2, and 7 and 8 is 1. So at no point is the difference more than 4. However, this case, this is not a stable group. So this is 1, 2, 7, 8. So as you can see, the difference between 2, 7 is 5. So this is not a stable group. So now your task is to find the minimum number of stable groups that you can form. So each student will go into one maximum of one group, and you need to split them such that all the groups are stable. So you need to find the minimum number of stable groups. So what are the states and what are the choices here? When considering each student, we have two choices. We can take him or her in the current group. So let's say we are building a group, and if we encounter a student, so our choice is we can either take him in the current group, or we can start a new group. We can start a new group with that particular student. So now, as the task here is to minimize the number of groups, we have to maximize the number of students in each group. So I hope the question is clear as until now. So I want you guys to scan this QR code, and this will lead to the Slido link. So, and this will lead to a quiz where you would have to come up with you would have to find the number of stable groups that has to be formed with a given array. So I'll give you guys about so now it should be live. You can see the question. Yeah, this is. I'll give you guys a couple of minutes. Just look at you're given an array and you have to find the minimum number of stable groups that can be formed with it. So try coming up, just use a pen and paper or use your mind and just find out what would be the minimum number of stable groups that you can form. Yes, you can start. Putting your answers in. You guys have time. You guys have 30 more seconds. Try to finish it off. Okay, if you guys didn't know, a stable group is such that in the sorted array, no two neighboring elements should differ more than x by more than x. So yeah, your task is to find the number of stable groups. You guys, I'll give you guys some more time if you guys didn't know what a stable group is. So I guess I'll stop the quiz for. I guess all of you have responded. So let's see the results. So 41% of you are given the answer, and that is you can form two groups. So what would it be like? So let's see. 2, 6. Sorry. So in this case, there are just two groups, and I'll come to the solution right now. So a solution would look something like this. We have to maximize the number of students in each group. Therefore, we have to group students with closer levels. So we can do that first by sorting the students in the order of increasing level. So you guys would have learned sorting the previous class. We can use the inbuilt function to sort the array. And now we'll go through each element, and if at any point the difference in level between two adjacent students is greater than x, so in that case we would have to create a new group, because there's no way we can not we can accommodate that person in the current group, because the difference in level is greater than x. So look at this example: 1, 2, 4, 5, 8, 9. This is already sorted, but and let's say x equals 2. So now, according to this approach, that we look at each successive element and we split at points where the difference is greater than x. So look at this. The difference is 1, 2, and 1 again. But between 5 and 8, the difference is 3. So there's no option, but we'll have to start making a new group. So according to a greedy approach, we'll get these two groups. So even in the quiz that we saw right now, you can do the same thing, and you can find out that there'll be two groups. So think about why it works. Again, we have to group students with closer levels so that you can apply the greedy algorithm. If it's not sorted, and we sort so that the students are grouped with closer levels. So I guess everything is clear. Can you guys respond if everything is clear? If you sort, you're not changing the neighbors. Yeah, the order of students doesn't matter. Anyways, they have asked in the sorted array of their levels, no two neighboring elements should differ by more than x. So the order of the student doesn't matter. We just want the difference between two neighboring elements should not be more than x. Hope that answers your question. So I guess I'll continue. So if you can, this will be the code for it. So I'll explain the code. This is this is just the main function. You get n and x as input, and the vector of the array, elements of the array. So this is just standard. And now you'll sort the whole array in increasing order. And this is the part where we apply the algorithm. So the number of groups is 1, and we'll go through each element. So we'll start with I equals 1, and we'll go until I is lesser than n. So that means you'll go until I equals n minus 1, which will be the last element in the array A. And we check if A of I minus A of I minus 1. That means the difference between the current element and the previous element. If that is greater than x, that means you have to increase the number of groups. So you do that throughout the array, and once you reach the end of the array, you can exit the loop and you print the number of groups. So I guess that's clear. Can you? I'll stay in this for a couple more seconds. You can try to understand what is it about. Yeah, all right. I guess we can continue. So now that we've looked at a common example, we'll now look at the limitations of the greedy approach. So it doesn't always work. That's because it can only be applied to a limited set of type of problems. So you can't apply the greedy algorithm to all the problems that you see in code forces. This is because the solution obtained by greedy algorithm may not be the best solution. So the problem will obviously ask you the best solution, but if you're doing the greedy approach, you're choosing the best at each state, not the globally optimal solution. So sometimes you might not get the intended solution. So we look at one example where uh, greedy approach fails. So now we'll just to say whether a problem can be solved by greedy approach, you can try coming up with counter examples where the greedy algorithm fails. So let's say you're given a problem, and obviously there'll be test cases given. So if you're unsure of whether you can apply the greedy algorithm or not, you can try coming up with your own test cases and apply your greedy algorithm on that. And if it doesn't work, then even if there's one test case where the greedy approach fails, then it means that the problem can't be solved with that approach because, as you know, your approach has to be the has to be general. It has to work for all possible test cases. If it works for, even if it doesn't work for one, that means you can't apply the greedy approach. So right now we'll look at one example. So yeah, consider that you have infinitely many coins with given denominations in the array D. Now we need to find the minimum number of coins needed to make a given value V. So let's say you have infinitely many coins, 1, 5, 10, and 25. And you are asked to use these coins to make the value of 30. So you need to find the minimum number of coins, mind you. So now think whether you can take a greedy approach to this problem and also try coming up with other test cases. I'll give you guys 30 seconds or something. Think of what approach you can take. All right. So I hope you guys have found something. So even if not, we'll look at possible solutions. So for this given example, 1, 5, 10, 25, and for the value of 30. So one might say that we'll take this greedy approach where at each point we'll greedily choose the highest value coin that we can take. So take because you're trying to minimize the number of coins, it would be beneficial for you to maximize the value of the coins. So this is a greedy approach where you just choose the highest value coin that you can take at that state. So in this case, you look at the array and you have to find the value 30. So what is the highest value that you can choose from these? Obviously, you can choose 25 because 25 is less than 30 and it's the greatest among these. So you will choose 25. And now you have remaining of, you need 5 more coins. So obviously you can't choose 10 and 25 anymore. So you'll only consider the coins 1 and 5. So even at this point, you would choose the highest coin. You'll choose 5 to get 25 comma 5. And this is indeed the correct answer. So if you think there's no other way you can get it with one coin, so the minimum number of coins needed is 2, 25 and 5. However, it doesn't mean that the greedy approach is entirely correct. So this is just one test case, and in this case, the greedy approach is correct. However, that doesn't mean it's correct for the whole sample, whole possible question. So, for example, try coming up with counter examples where the greedy approach might fail. I'll give you guys a minute. So, yeah. Yeah, I want you guys to scan this QR code. So in that there'll be multiple choice question where select the you can select the examples where the greedy approach might fail. So yeah, I want you guys to scan this QR code. And you can respond to the multiple choice poll that's there. Keep in mind you have to find the cases where this greedy approach that we discussed would fail. So we discussed that we'll just choose the highest value coin. You need to you need to see if there are test cases in those options which would not work with the given approach. And also remember that there are infinitely many coins in each uh, in the given denominations. I'll give you guys 30 more seconds. All right. I hope you guys have finished responding. Yeah, almost all of you have. So majority of you are wrong. You would so look. So let's discuss it. 137 and value of 20. So obviously you can choose two coins of 7 and two coins of 3, and that in that case, oh yeah, in that case you'll be able to see that you'll choose two 7 coins. So you'd get 14 and you need remaining of 6 coins. So obviously you can't choose another 7. So you would choose 3. You need 3 more coins. You'll again choose 3. So in that case, the greedy approach works. However, if you look at option B and C, you can't, that wouldn't work. So yeah, I'll end the poll and we'll discuss how this would we'll discuss with one example. This is the option B that you would have seen. So given that it's 1, 2, 5, 7, 9, and V is 12. So according to the greedy approach that we discussed, we would first choose 9 and we'll have a remaining of 3 coins. And now for the remaining 3, you would choose 2 and then a 1. So you would get 9, 2, 1, and that is 3 coins. However, if you notice carefully, we could have picked 7 and 5. So We didn't these two coins, which is just two coins. Yeah. So obviously, this is a classic example where the greedy approach fails. You can't just blindly assume that it would work. And so this is the importance of coming up with more test cases. So similarly, even option C would have is almost similar to this. So I hope you guys understood. There's no intuitive way where you can tell your algorithm to choose 7 and 5. You can easily come up with more test cases where we can't apply the greedy algorithm. So this is a very big limitation of the greedy approach. That is, you can't cover all possible cases. You're just choosing the best option at that point and you're hoping that would be the best. So in such cases and a lot of problems, you might not be able to apply the greedy approach. So you have to remember that. So then how do you, so some of you might wonder, how do you actually solve this problem? So this requires a more advanced topic known as dynamic programming. We'll not be going into that for now because it's a bit more advanced. However, you can keep that in mind. You can search up on it if you want. But yeah, in this case, you can't apply the greedy approach. So I hope that's clear. So yeah, all right. Okay, so you guys want me to? Okay, I'll repeat this once more. So look at this. You need a value of 12, and you have infinitely many coins of 1, 2, 5, 7, and 9. And the greedy approach we discussed was we'll greedily choose the highest value coin that we can take. So in this case, we would choose 25 and 5 for value 30. But look at this case, 1, 2, 5, 7, and 9. If you use the greedy algorithm, you would choose 9 first because that is the highest coin that you can take. And later, now you need just 3 more coins. So obviously you can't pick 5, 7, and 9. Out of these, 2 is greater than 1. The sum of it is which is 12. And this is 3 coins. So we get this by using the greedy approach of choosing the highest value coin. Again, but if you notice carefully, we could have picked 7 and 5. It's just 2 coins, and 7 plus 5 is 12. So you can see why the greedy approach fails, because we didn't even consider choosing 5 as well. So there's no simple way to tell your algorithm that, okay, I want you to do this. Approach fails. I hope that's clear. Hmm. Option C. So 1, 2, 3. If you guys looked at the multiple choice question, 1, 2, 3, 5, and 6, and you need a value of 10. So using the greedy approach, what you would do is you would choose 6, and you need remaining 4 coins. And and as I mentioned, there are infinitely many of each coins. So you could have picked 5, 5. So that is pretty much similar to this case. So which that is why that particular case fails in the greedy approach. So yeah, I hope that's clear. All right, and I hope we can continue. So this is a code forces problem. So let's see. You need not go to the link. The question is here, and you need not code it right now. We'll just discuss the solution. So you're given 2 arrays A1, A2, until AN, and B1, B2 until BN. So these are 2 arrays of length n. So you're given these 2 arrays, and in one operation, you can choose any integer I from 1 to n. So that would be your index. So AN should be equal to max of A1 until AN, and Bn, which is last element in the array B, should be the elements of B. So again, you can see that maximum of a bunch of numbers denotes the maximum number among those numbers. So for example, max of 3 comma 5 comma 4 will be 5, and maximum of 1 comma 7 comma 7 comma 7 is 7, and the maximum of 6 comma 2 would be 6. So you need to use these operations to find out whether you can satisfy these conditions.